Good day, everyone. In this video, we are going to give an introduction to Python programming using the programming environment called Google Colab. So exactly what is Google Colab? Well, it is a product from Google Research that allows you to write and execute Python code right in your browser. So there's no configuration of your computer required, nothing to install on your computer. Using Google Colab is easy to create, edit, share Python or Colab notebooks. It's free. Now, let us see exactly what a Colab notebook is and how to create one. To do it, what you need to do is go to your G drive. All right. And once you're there, you look over to the left and you see this new. And so you select new and you come down and look for Google Colab. And there it is. If Google Collaboratory is not installed, you would go further down to connect more apps and install it. So let us select Google Collaboratory. When we do that, a blank, empty Python notebook is opened up here. And we can see the cursor, and it's in what's known as a cell. There are two types of cells. There's code cells and text cells in these notebooks. Now, code cells are for code. And you can enter let's enter something simple like 2 plus 3, which is a Python command. And then to execute those Python commands, you hit either that play button right there, or you could hit Shift Enter. So let's try that. The first time it takes a little while as it's connecting to the engine. It's connected now. So 2 plus 3, and here's the result down here. You could go up and edit what you put in that cell. Let's subtract 1 and execute, and you have the result. So that is a code cell. Here is a text cell. And to enter text, so what these notebooks allow you to do is have code along with explanatory text. And so we double click and we could enter text in this cell. I'm going to give it a heading tag and say this is some text. And there it is. Now further, you'll see up here, if you select file, you'll see how you can open up notebook. So if we select open notebook, notice the options that you have. You can open notebooks that currently reside on your Google Drive. You can upload notebooks that are on your computer, not on the drive. Or you can look at notebooks that are on GitHub. So for example, if you select GitHub and you want to download or open a notebook that's currently stored on GitHub, you would need to know the repository name. I've got a repository name here, and you can click and select and just click on the notebook and it will open it up. So there's a notebook that we have just downloaded from GitHub, and we can work with this. Now, if I come up here and try to save this notebook, if I say save, you can't save this copy. It doesn't allow you to change the copy that was on GitHub. But what you can do is make a copy of this and save that in your Google Drive, and then you can edit that. So that's why it's prompted. You said you want to save a copy in Drive, and we'll click yes. And notice how it changes the name. So previously the name was Notebook 2. Now it is copy of Notebook 2, which is stored on your G drive, and you can edit it and change it and save it and update it. Now let's go and look at doing some programming and Python programming. And so here I have a notebook with some text already here. And the first thing I want to take a look at is how we declare a variable in Python. That's simply done by, let's say we have a variable x, so we want to assign it to the value 22. And hit enter. And so now x has this value of 22. If we want to see that, we can type x in this next cell and hit enter, and it will display what the value of x is. Now if you take 2 times x, it's going to give you double what x is. However, it's not going to change the x value. So if I hit x, it's still 22. But if we want to take 2 times x and make x equal to that now, okay, so this is saying replace x with 2 times x. It's like an assignment operator. And let's do that. And I want to put x on this command as well. And so now we can see x is 44. A second variable I might assign is y and make that 1.23. So y is a variable as well. If I type whos, the command whos, that will show me my current variables that I have. And we notice there's 2 variables we have now, x, which is an integer, value 44, and y, notice y, it's a float, 1.23. So these objects, Python is an object-oriented programming language, so everything is considered an object. They have a type. I can see what the type of the object is by typing type x, and it returns an integer. Now to do math in Python, it's best to use the Python module called Numpy, which stands for Numerical Python. So that adds to the ability of Python. So what we do is to use this module or library, we have to import it into Python. And this is the command. We say import numpy as we give it a name. We'll call it np. So now we could do math operations like say we want to take the square root of 9. So notice this command square root, we have to prefix it with np and shift enter to see the result, and we have 3. We could also do np.log. Now notice when I hit numpy dot and hit log, I can hit a question mark after that and get what is known, if we look over here on the right, get a doc string that explains what this function does. Okay, so it's np.log. It tells you how to use the function and what it does. Now if you come down here, we'll notice what this np.log does. It computes the natural logarithm. So unlike your calculator, the natural logarithm is log. So if we take the natural logarithm of 100, that will return the answer. If you want to use the logarithm to base 10, it's log 10. Let's take the logarithm base 10 of 100. We know the answer should be 2, and that's correct. Now, it gets a little tedious putting this np dot, like np.sine, having to prefix all the time. So if there's certain functions you're going to be using a lot, what you can do is type the following: from numpy import sine, cosine. Hey, NumPy knows what pi is equal to as well. And once you have done that command, import sine, cosine, pi, you can use it without prefixing it with the NP. So for example, sine of 2 and pi. It should just return a value of pi. Okay, so that's NumPy. Now, next we'd like to briefly talk about NumPy arrays. An array is a grid of values, and we will primarily be discussing just one-dimensional arrays. It's like a list. Let me show you how to create a NumPy array, and I'm going to call it X. So X is going to get reassigned here. It's an numpy.array. Then you could just put the values you want, like 1, 2, 3. Simple array. Okay. And I misspelled array. Let's try that again. All right. So we declared X as being a NumPy array, which is a list of the numbers, just happen to be 1, 2, 3. If I want to view it, I hit X to see what it looks like. There it is. If we ask for what type of object that is, it's a NumPy n-dimensional array. Now, to access elements in this array, we use the following method. We type X bracket with the index number. So if I ask for X0, notice it gives us the first entry in that array. So that shows us that Python uses, and you can add a comment to a line here by using a pound sign. So Python uses what's known as zero-based indexing, meaning that the first entry has index 0. If we ask for X1, that gives you the second entry in that array. Now, we have some commands for some handy commands for creating NumPy arrays. The first one we like to show is numpy.arrange. And you can hit a question mark to see how that works. If you look over here now in the doc string, you can give the beginning value of the array, the end value, and the step. So it's going to give you a list of numbers starting with this value, ending with this value, and with the increment, whatever the step value you give. So if I type np arrange and just give 0, 10, it gives us the step value is 1, but notice it does not include the final value. If I come back here and change the step value to 0.2, notice what we have, 0, 0.2, 0.4, np arrange. And of course we can take that and save that array, call it Y, and then if we want to look at Y, there it is. A second method, important method of creating a NumPy array is the linspace, np.linspace. So you give the starting value, the end value, which I'll make 10, And here the difference is you give how many values you want. So I'm going to put, so give me 50 values, 50 numbers, evenly spaced between 0 and 10 is what that will do. Let's take a look at it. There they are. That's an array, and it's 50 values between 0 and 10. Notice the difference here with len space gives you the final value. Now I have an array X. Let's look at that. And let me create an array Y equal to 2 times X. Let's see what Y looks like. It's 2, 4, 6. You could take two arrays and multiply them together. And what's going to happen then is it's going to multiply it on an element by element basis. X times Y is 1 times 2 is 2, 2 times 4 is 8, 3 times 6 is 18. You can take the sum of the elements in an array by using the command sum and give it an array you want. Let's check that out. Yes, if you add everything up in this array X, it adds up to 6. Something that's very useful, which you'll see, is the following command, np zeros. It says, hey, give me an array of all zeros and whatever size you want it to be. Likewise, you can have np ones. Now, X is still up here, and suppose you want an array of zeros, and you want it to be the same size as X. So this says, give me an array of zeros, underscore like. So I want it to be the same size as X. So notice what that's going to give us. It should give me, since X has 3 entries, this should just have 3 entries. Now, if we have this X array, we apply a function to it, like X squared, that function is going to get pushed into each entry in the array. X squared, what's it going to do? It's going to square each entry. Or, if you want to compute the sine of each entry in the array. So we take np sine of X. This is going to be the sine of 1, sine of 2, sine of 3. So this function gets pushed and applied or mapped to each entry. Next, we'll take a look at plotting. So to create plots using Python, we load this module called Matplotlib or Matplotlib. Very similar to plotting using MATLAB. So here's the command to import Matplotlib. We're going to import matplotlib.pyplot as plot. So when we use it, plot will be the command. So let's execute that. This command here is if you're running on a Mac, this command will take advantage of the Retina display and give you better quality plots. So we're going to do that. So let's show you quickly how we can create a simple plot. We're going to say plot. The command is .plot. In this case, I'm just going to put the numbers 1, 2, 3, 7. And then in quotes, put the plot marker that I want. So there it is. Now notice when we did this plot, we only gave the Y values, no X values. So it makes the assumption that the x value for the first entry is 0. So see, you got 0. When 0 is my output's 1. When my input is 1, my output is 2, etc. Now what we could have done is just did a plot and give those values 1, 2, 3, 7 without a marker, and it will connect the dots. Okay, notice no marker here. It connected the dots. Now this is all in one cell. I could do other commands like say give me a grid, give me a title, call it title, and then when you insert your title, it's a string, so you got to insert it in double quotes, and we'll call this simple plot. If you don't want this, you could suppress that by ending this with a semicolon. There's our simple plot. You can put labels. Plot dot. This is show. Plot dot x label. Let's see if I remember how to do that. Okay, no, that was not right. Okay. X label. There we go. We got an X label. Now to change the size of this plot, we'll come back up here and do this command. Plot.figure. And notice when you start to type the command, this little window comes up and helps you out. So I can specify the figure size. Fig size equal to, let's make it a 12 by 8. There we go. Now, it could be that you need to save this plot. You could do that with plot.save fig. Is the command. And if you need to know the syntax for this, just hit a question mark. Let's do that. And it opens up the doc string over here. So plot.save figure, what you need to give it the file name that you want to save it as, and you can specify the dots per inch and other things. So let's go back in there and do it. So let's save it as plot.png file. It'll look better than JPEG. And I'm going to specify the dots per inch to be 300. Okay, so this plot has been saved. Let's come down here. Well, it's been saved, but right now Colab is not really connected to your G drive. It's saved in like a temporary location. If you turn everything off now, you do not have that file plot. So one way you can handle this is import this from Google Colab, this module called files. Let's run this. So what we're going to do is show you how to download the file to your local machine. And then, okay, we're going to use this module called files, and we'll say files.download and give the file name that we want to download. And I believe it was plot.png. And when you do that, say it's downloading, and there it is, downloaded on our machine. Let's take a look at it. So now it's stored on your machine, and you can open it, and there is the plot saved on our machine that we just created. One other plot real quickly here. If I come back up and make another plot, let's plot the sine function. Here, let's do this. Let's say, hey, add some code. Let's add some text, that is. Let's add some text. And so say what we're going to do. We are going to plot the sine function on the interval 0 to 2 pi. Let's do that. To plot the sine function, I need x values between 0 and 2 pi. So I'm going to let x be equal to linspace 0 to 2 pi and give me 100 points. Okay, so I'm creating my x values. There they are. It's numpy.linspace. We have to prefix that command with np. So now we have all these x values, if you want to see them. There they are. All right. So to plot, notice this, plot x comma sine x. Now if I say, hey, just show me the markers, it's going to look like this. But if I remove that, it will connect the dots and give you a sine plot. Okay. Okay, so for loops are kind of important for the work we're going to be doing in this class. And to do a for loop, here's the basic syntax. I could say for I in, and I make a Python list, 1, 5, 9, just random numbers. For I in some list, colon, then it's going to iterate through this. I is going to take on all these values. We could just say print I. And so it went in, took on the first value, printed it, took the second value, printed it, etc. Now, x, if x is equal to np arrange 10, if you just give the final values, let's see what x is equal to. Here's x. All right. So I could say for I in x, for I in x, print I comma I squared. Let's try that. So it printed the first value, then it squared it. Okay. So that's for loops. You could even do something like this. If you have a string, here's a string. Strings are text. They have to be enclosed in quotes. This is a string. S. So S is storing that. And we do whos so you can see now. Here's all of our variables. And we got S. It's a string. And its current value is, this is a string. So what I could do in a for loop, I could say for I in S, print I. It goes in and selects each value in that string and prints it out. But notice when you do a print, it ends with a carriage return. If you don't want it to end with a carriage return, you could say end equal to, you could just put a tab. So hey, after you print I, don't hit a return, hit a tab. Let's see. See that? What it printed was, this is a string. It printed it and hit a tab. Okay. Hey, you could do a method on I, which is a function I upper. So what this is saying, it's going to take each I letter in that string and print it in uppercase. Okay. To define functions in Python, this is the syntax. You start with the DEF. Okay, that means define. And then you give a function name. And let's define a function that's going to take the average of some numbers. I'll call it my average. That's the name of the function. And then you list what your inputs are. Hey, I'm going to write a function that will take the average of two numbers. We'll label them A and B. You end that with a colon. But now, see, there has to be, under the function, it has to be indented so you know what comes under this function. And so what we want to do is to average those numbers. So I can say temp is equal to A plus B divided by 2. And say return temp. So there we have defined our own function called myAverage. Takes two input numbers, it's going to compute the average and return it. Let's try it. So to call the function, we just type myAverage and put a couple of numbers in, 2, 3. And there's the average, 2.5. Now, if we type myAverage with a question mark, saying, hey, I need to understand what this function is doing, it's going to come up here and say, if you look over here, there's no document string to explain that function. So this was not good programming here. Let's go back and enter a doc string. We're going to put 3 single quotes and explain what the function does. We'll say, hey, this function inputs 2 numbers and returns the average. And end that with 3 quotes. So that is a that's a document string. You come down here now and execute this cell. Let's see that the function still works. Let's call it with the numbers 2, 3. Yes, it works. But now notice what happens when we do a question mark. Help comes up, and under the doc string is written, this is the explanation of what that function does. Okay. Like to conclude with an example where we're going to numerically compute this definite integral right here. The integral from 0 to pi sine of x. Now, hey, this is a a text cell. And how did I get this integral sign and all of this? Let's double click it and see. You can enter what's known as Latex, okay, which is a typesetting language to produce these mathematical symbols. So this is Latex. These double dollar signs tells Colab that this is Latex here, and there's some more Latex here. And so when we execute this cell, it renders this. So let's just look. Suppose we want to approximate what this integral is using this Riemann sum. Well, I'm integrating on the domain of 0 to pi. So the first thing I want to do is discretize that domain. Okay, so come up with x values. And so we got to decide how many partitions we want in that domain. Let's make it 100. So I'll say n is equal to 100. And I'm thus now going to figure out what dx is. Dx is equal to pi minus 0 divided by n. Okay, so that's dx. Now, to get the x values, we'll let x be equal to np.arange from 0 to pi, and the separation or the step size is dx. Let's just do this part first and see what x looks like, see if it looks right. So I got x values on this interval 0 to pi. Yep, here it is. And here they are. There's 100 values. Now, what you could do here is to confirm that it's 100 values. You could say, what's the length of x? It's 100. Okay, so here we go. Let's do this. To get the integral, it's going to be equal to the sum of sine of x times dx. See, sine of x is going to be an array of all of these values, f of xi, and this is going to multiply by each dx. So those two arrays are going to get multiplied by each other, and then you're going to add all the results up. Now, this integral is equal to exactly 2. Let's see what our approximation gives us. 1.999. Now, of course, you could use Simpson's rule, use some other methods and get even better than that, but that's pretty good. Okay, so that's just an application showing that we used Python and what we've learned and numerically approximated that integral, got 1.99. Finally, when we say mounting the Google Drive, right now, the Google Drive, your G Drive, even though you went, it's a little confusing because you went to your G Drive to load Google Colab, but it is not, the G Drive's not mounted, meaning if there's some data on there and you want to transfer to this notebook or transfer data back and forth, you have to first mount the drive. And to mount the drive, you can come over here, because right now if I use this command called lis, which is an OS command, okay, it shows that plot that we saved, it shows sample data, but I cannot see my Google Drive yet. I cannot look at the directory of my Google Drive. If I go over here, hit this folder, and hit this right here where it says Mount Drive. So what this is doing is permitting this notebook. So we don't want our notebooks to access the drive and start either storing stuff on the drive or taking stuff off the drive until we give the notebook permission. And we say, yes, connect to Google Drive. Now to do that, it's going to say mounting Google Drive. And let's see if that worked. If I do lis, now notice the difference. You see drive. And I could say change directory to drive. And now we're here. Let's do a lis. And we could say change directory to my drive. And if I do lis, I can now look and see my Google Drive and see the files that are there right here. See, if I go up and look at my drive, here's the files, and here, like, I've got here. This is a folder called Colab Notebooks. If I actually go to my drive, notice I got a folder, Colab Notebooks. Well, so what we did in this video is very short introduction to this really nice free software, Google Colab. Allows you to get right in and develop Python code and share it, store it on GitHub, execute it, and there's much, much more to this, but this is a beginning. Thank you for listening.